Bet no to stīku vajadzēs atpakaļ. Hello. Yeah. Yeah. Almost there. Oh, es aizmirstu. Just a second. Es viņu pieliku. Nu, es nepapildu. Don't trip on it. Klausīsimies, kā jūs dzerat alu.
Welcome.
Jā, šitam man nevajag. Bluetooth. Okay. Nē, nu jā, bet... Just a second. Es pieteicos. Okay. Hello. Is anyone watching the stream? No? How is the audio okay? Okay. This time we're using Slack chat. Don't even bother writing on YouTube. Wait a minute. Yeah, great. Okay. So today's topic, everyone ready? I'm gonna close the door. I thought everyone was already tired of the previous picture that we used, so I changed it. What do you mean? Didn't fix it? No, that doesn't matter. Okay, so today we're going to talk about request caching. Since Black Friday is coming, it is like important topic, at least for some of the projects. And so I'm gonna speak about what we did in case of Arc and what we're still doing there. So to understand why we did what we did, we have to look at how the standard Hybris project is currently in Arc, in Perl. So usually we have like 3 cores, I would say at most, 3 nodes with 2 cores on each. And then on the database and Solr side, we can have as many as necessary. Database usually has more than 2 cores per server. Yes, and of course, the question is, why are there so few CPU cores? And the answer is quite simple, that by default we use SAP uses the per core license model, and they can be quite expensive. So when we looked at Arc, like this is I wouldn't say typical day, but this was quite busy day for Arc, and these are screenshots from Zabbix, and you might think, well, it looks okay. It's not ideal, but could be okay, right? Raise your hands. Anybody agrees this is okay? Good. Okay, a few people think it's okay. So how about now? This is the same data, just the load data, the same day, and you can see all 3 of the nodes here. Do you see something peculiar here? I'm gonna help you out. Yeah. So the load is about 2, and in Unix terms, the load should never be above more than you have cores for the server. So obviously, in these. It's gonna work, right? So in these places and this big spike definitely made some impact. And basically the site started to become slower and slower and slower. It didn't crash, but it was noticeable. And actually in all of the previous Black Fridays, it has been that the requests on Black Fridays are just slower. Yes, so well, Solr and database is quite happy, Hybris is usually quite tired. So how do we solve it? So we looked at the last Black Friday access logs, and I'm gonna quickly switch. Sorry? Okay, sorry. I'm gonna fix that. So we looked at data, and we noticed that 50% of all the requests going to Hybris were made from these recommendation blocks, like standard carousels, right, of products. And they're everywhere. They're used in Sunsin recommendations, they're used in CRM recommendations. They have like, basically they're everywhere. Wherever you go, you're gonna see them, and there are a lot of them. And the problem is that they don't only make requests to Hybris, they also make requests to CRM. Because they want to see this availability, if the product is available or not. And if it's not, then they're not going to display that product. Yes, so a lot of requests. Then again, like 13% were made of medias and static resources. And the rest were basically product pages and everything else. Back to slides. And then we thought, how to fix it? So no request, no problem, right? Because we don't want to hit these 2 core servers. They're quite weak, they're quite busy. And then we figured out we would come up with something, and we came up with caching. We introduced a custom cache for recommendations, and they are That's basically a Spring Boot-based project. It works as a transparent proxy microservice. And to make it fast, I listened to Arvids. He suggested to try Undertow and the reactive approach that basically allows you to write asynchronous non-blocking code in Java easily. And so then, yeah, I'll show you. It's easy. It had some bugs actually, but that's a different story. So we cached the full recommendation blocks. Previously, it generated some ugly HTML that's thing from the past. So Herbert's helped with that. He changed all the recommendation blocks, first of all, to make them basically stateless. Previously, it had information about customers bought products for digital books. It had information about the favorites. So we removed everything out from the recommendation blocks. We added both the friend prices and anonymous prices there, and now we can cache the JSON. And additionally, and we can also cache the separate product parts for the personalized recommendations from Sunsim. And then additionally, we thought, okay, let's try and add Nginx as well. We obviously cache UI, VRO, and we also are now caching medias because they use them for CMS purposes. And that uses the standard Nginx caching module. And yeah, we start caching on the third hit. So if you look at the Nginx part, it's quite simple. We have a message to this thing. See the proxy cache path. Here is the path on disk where you want to store the files. Then we tell that to use the same disk in case temporary disk is on a different disk, so you don't have to move. Then you define the zone. So in this case, it says 10 million keys max, and then max size 13 gigabytes. And after 12 hours, it will just remove inactive stuff. And then it has some configuration where it defines for how long it caches different response statuses and so on. Then it starts considering it to cache after the third hit, and then some other things. And then also for the debugging and just to know what's going on, you add this xcache status header to the request. And then when you make a request, you actually see if it was coming from the cache or not. And we haven't removed it in production currently, so you can actually check if it's hitting the cache or not. And then we have the Perl cache. So as I said, it uses Spring Boot. So everyone over here probably knows how to work with Spring by now, more or less. At least, yeah. And so the Maven handles the building and dependencies, so it's easy to set it up. We use annotations for configuration, more or less, so no XML files like in Hybris. And then the most important part is that we use this reactive non-blocking asynchronous approach. And to use that, you need support from the server. Tomcat doesn't support that currently. So you can use Undertow or Netty. And actually, Undertow, I think, actually now uses Netty under the hood. But basically, it adds some nice configuration options. And then for the requests that go to Hybris, we use this reactive web client. And so how does it work with this reactive stuff? So in reactive approach, the method returns immediately. The callbacks are set, and they're executed upon different events, like on success, on error, timeout, periodically, and so on. Then the framework basically keeps references to those objects and does some work once there's activity on a socket or on some sort of, well, whatever. Basically, in most cases, it's either TCP Unix socket or might be some file handle or something like that. Yeah, and then while the framework waits for the data, the threads are free to do anything else. So they're not occupied. They're just references, and then, and this basically results in higher throughput than using block threads. We have seen with Hybris, for example, that when you get a lot of customers and, I don't know, for example, Tomcat, you run out of Tomcat threads or something like that, and basically site starts to block. even if you're just requesting like static media or something. You definitely can see that on Windows. And yes, but the downside is that the developers have to get used to the approach. You cannot write the good old blocking style of code where you just write it line by line. But since we have also worked with JavaScript, we're quite used to like onSuccess and so on. It's just slightly differently structured. So in other words, it's fun, especially in the beginning. Afterwards, when you start hitting the bugs, maybe not so much. But overall, it was a good experience. So, and how does the Perl cache work? Yeah, you can't really, I guess, see maybe. So we have the URL to the recommend, and then there's this campaign unique identifier, right? The CMS item page. So we take that as a key, and the Perl cache then checks if it already has the key. If not, it makes request to Hybris. And then once it makes the request to Hybris, it stores the response in the block cache, and additionally, it also stores the separate product parts from the response, because on the response you can have like some headers, and for the specific block, it's like prepared recommendation block, right? But it also has these product parts. And we made it so that the product structure for JSON is the same as in other places where we use recommendations. So we can cache the separate parts as well and reuse elsewhere. So when the personalized recommendations come in, yeah, and basically for personalized recommendations, you just get a list of product codes. Because Sunsync, for example, they return a list of product codes. For Google Analytics, these enhanced e-commerce, you also need to you get these product codes from the JavaScript, so it's we use it in multiple places, and then the Perl cache actually builds the JSON, and yes, for the product parts that you already have in the cache, you take them out of the cache, and for the ones that are missing, you ask Hybris and put them in the cache. So here is the configuration file. Well, not all of it, it didn't fit. But basically, we use the YAML config. It's the same as the properties files, but you have some sort of a structure. It's nice. Then here is the whole REST controller method for block caching. So basically, I'm going to change it to this one. Basically, we immediately return this cache future. So we get it from the loading cache, which supports asynchronous approach. We ask for the specific key, and then we return mono. And in the mono, we say, OK, create mono from future. Mono is this reactive object that Spring uses. And the future is this. Futures are these previous objects that were used in other frameworks in Java. And then basically, once the cache actually loads the data, it will return it, and then the mono will trigger, and then it will trigger generating this response in which we set the C tag for caching in the browser as well. We set some expiry time and so on, and then we set the body. So quite simple. This is the controller part, and then here's the cache, and this is so basically all of the cache for the blocks. For parts, it's slightly more complex. So here we define the size. We store like 10,000 blocks and 100,000 products max, but it hasn't been as high until now because we expire it after 1 minute. Because we have to update the ATP data coming from CRM, basically if the product is available or not. So we cannot cache it for a long time, but we cache it for a minute, but it helps a lot anyway. And then, of course, we can set this refresh after write, which is a very nice feature, which means that we can request, in our case, after 45 seconds, if the customer comes in and asks for this specific part, it will immediately return the part that it has in cache, but it will also ask the backend to update the value from the backend. So customer gets it fast, and then the slow request to Hybris, no one has to experience that. It just happens in background. Yeah, then we also write some stats, and here we use this, and this is the important part, the load data, where we pass the key. We just say, web client, hey, give us this data, add the cookies, add some headers, and on success, update the cookies in case something has changed, and yeah, change, cache the individual parts, it goes to a helper function, and then just return the response. So it's quite simple. Then we also, since it provides some monitoring, we added the JMX management beans. So from there we can both monitor and also do some things like invalidations, either for specific keys if necessary. Well, currently we cache only for a minute, but in case we change it, it's easy to work with that. So here are the statistics on a pretty much more or less regular day. On the left side we see this cache rate. During nights it goes almost to 0, at least for blocks, yeah. And then during the day it is usually above 50%. And during peaks it can go much higher. And then also, yeah, here we can see we have approximately 2036 parts and 285 blocks at this time in the cache. Then we have the same statistics for each type. This is actually Zabbix, but it uses Grafana just to display the data. But you can view it through Zabbix if you prefer. Yeah, here we can see the miss count, eviction count, hit count, and so on. And here is a nice example. So here on the bottom, this red line, this is the miss count. And this is on a day when Arc sent out 700,000 emails. And so you see that the peak came in, right? So while the red line increased only slightly, which is the miss count, the hit count actually and the actual customers that came in, it increased dramatically. And so it was quite useful because at least the caching part was very, very effective. Yeah. And also it doesn't only help with that, it also helps with reducing the overall load time. So here is the homepage before. So we can see these numbers, right? Like more than a second, these are these caches, these recommendations, product proposals, so on. And overall, the page loads in more than 3 seconds, right? After the caching that we added, so it basically changed to this. So you can see now it's like 30 milliseconds for these caches, these blocks which are cached. And overall load page time, like for the home page, is now only like 1.5 seconds or so. So there's a big difference. What's next? Yeah, next is, since Arc didn't want to buy additional cores for other pages like product pages and checkout and so on, we will have to optimize basically every single page we can. And so currently what we're trying to do is making product pages stateless as well. So in order to cache them in Nginx or in Perl cache, we have to make sure that there is no user-specific data. So we're moving out like the top menu when you're logged in, we're moving that to JavaScript. We're moving out, again, this logged in, logged out pricing from the product page, and basically we're gonna make more pages cacheable, like the full home page, the full product pages, and so on. We'll see how it goes, but our plan is to make it in a couple of weeks, because Black Friday is almost here. Yeah, and we don't really have time and no options. Yes, and then yeah, hopefully we survive the Black Friday. That would be nice. So that was all from my side. Any questions, maybe? Questions?
Do you expect that this will be the best Black Friday for our program?
I know that they expect that this is going to be the best Black Friday.
From performance perspective.
What I have seen from the log files is that on every Black Friday, and from experience when I've checked it when I actually worked on the project, because currently I'm not really actively involved, I just joined because I was slightly concerned. On every Black Friday, every page loads like 2 seconds slower than on any regular day, right? So it means that there wasn't enough resources for years. Is it gonna help? I hope so. It's certainly gonna help a lot, but is it gonna be enough? I'm not sure yet.
So you're trying to survive without the difference.
Yes, we have to survive with the 6 cores. As I said, my laptop has 12, right? So that's the difference.
That picture from first technical space.
Yes, I think it was the first technical spaces. Or one of the first. Anyway, I thought it's fitting. Yeah.
Second.
Yeah. Yeah.
That's where you're
Okay, so the second. Yeah. Okay, any other questions? Other than the caffeine cache, I did. But what I looked for was basically, so it would be actively maintained. Because this asynchronous non-blocking stuff is not really extremely stable, I would say. If you go to Spring framework and if you go to Caffeine and other those web client, if you go to their GitHub, they get a lot of bug reports. And so, for example, one thing that I noticed was, oh, I have this feature. Luckily, they fixed this bug a month before I started, right? Otherwise, I would be in trouble. But yeah, I chose it because it supports this non-blocking approach, asynchronous non-blocking, and yeah, I looked at some performance metrics and so on as well, so it seemed fitting. And so far, it looks like it's working nicely. Oh, I forgot to mention, when I did the benchmarks, so without it, you can request about, well, depending on the system, but per core, you get like 50 to 70 requests per second, and then the performance starts to degrade. It becomes slightly slower on these 2 cores. With the caching, I can get, of course, when the data is already cached, I get something like 70,000 requests per second, which is quite cool. No, I meant, yeah, the separate. Yeah. Well, as I did show previously, their page load was, since it asks to CRM for the data, it was more than 3 seconds. Now it's 1.5. So. Depends. The static resources don't use that much time, so they return lots faster. I approximately said that the node would be able to handle, no, not node, but all 3 of the nodes would be able to handle about 2,000, but from what we saw, it was actually slightly less. So 1,800, and then it becomes slower and slower, and it works, but it's like a lot slower. And no, I mean like concurrent users, because I don't know, it depends, like each page has, for example, homepage has like 15 of these recommendation requests. Product page can have from 2 to, I don't know, 5 or something like that. And if we change it from 15 on homepage to just 1 or 2, then that's great. Yeah, Alex says. Yep. As I said, we update the cache after this. Well, either if it's not there, we obviously have to put it in cache, but then we update the cache after these 45 seconds that we have specified. Yeah. So we specified 45 seconds. After 45 seconds, it makes a request to Hybris, but it does return the cached value immediately. Yeah. We made it configurable. Yeah. So we're actually, good question. We're actually currently running it on like a load balancer server. It's not the actual. Sorry. The load balancer. Long story. They have a Netscaler appliance which runs somewhere we don't know, and then we have HA proxy load balancer on the same HA proxy load balancer, which also has only 2 cores, but it has like 10 gigs of RAM. We run this cache, which uses like, I don't know, 5%, 3% from all the CPU. Even during those spikes, it didn't even move basically. So it's quite effective. And yeah, the caffeine benchmarks say that caffeine becomes very effective if you have more than 2 cores, but it runs fine on 2 as well. So, yeah, at least. I think this whole Perl cache thing can be used more or less as a template. No, the thing is that, as I said, it will cache everything that is stateless. So if you can change your recommendations, if you have them, to not contain anything user-specific, and then it's basically cacheable, then you can use it. But I'm not sure if you need it. For example, in Nurengru, they don't really have that many concurrent users, because from what I've seen, Arc is one of the most popular, or maybe the most popular e-commerce sites that we have in Perl. Well, Rimi is probably gonna have more concurrent users, probably. Yeah, probably. But yeah, not sure if it's gonna be necessary for every project, but certainly if you see that you have squeezed like all kinds of optimizations and you still have to use the ERP system synchronously and so on, and you need something, then you can look at this. Yeah. No more questions?
What database for
No, there is no database. It just holds it in RAM, actually. That's why we have this set size. I thought it's going to use a lot of memory, but in reality it doesn't. Like, I can probably quickly... I'm not sure if I used the word stream, but I used asynchronous non-blocking because it just makes sense in this case. Let me quickly check here. Yeah, I don't have the correct type set here, but basically the old gen is something, what is it, like 7 megabytes or visual? No. How much time do I have? I'm minus 2 minutes. Just a second. Yep. Yep. Show up. Show up. No, I'm stealing someone else's time. Where was it? It's not here. Well, like heap usage 200 megabytes, and the old gen is like 7 or something megabytes. So it's not using that much resources. When it's gonna become a problem, we're gonna probably move it to a different server. But currently, it just runs on the same system. Sorry?
Do we charge any license cost? Because we saved quite a few bucks, right? Because they didn't buy.
Yes, we maybe saved quite a few bucks for them, but we don't charge any license cost for this.
Per customer.
This is only development time, so yeah. If you want, you can look into that, but I'm not sure if that makes sense. Yeah. Okay. Thank you. Що, запілець фото.
Okay.
Protams, mēs tā nesam. Viņu vajag?
It's not.
Jā.
Good. So should I wait or can we go? A minute. Okay, sure.
They're not coming?
All right then. Okay, I'm Rainis. Today I'm going to tell you about how we have implemented the Yarnia B2C storefront. Right, first things first, what does our storefront consist of? We have Node Package Manager to get all the dependencies. For styles, we use Bootstrap 4, which we upgraded from the version 3. It was quite a process. And SCSS for styling. We have Vue.js driven checkout. And for other pages, mainly we use jQuery and ECMAScript 6 to get the dynamic in motion. And also with Node, we get various small utility JavaScript libraries for date picking, validation, and such. And in the end, all the JavaScript is compiled, combined, and compressed by Gulp and Grunt. So our team is me, Jānis, Boguš, and Richards. Usually the flow for new designs is that designer from external company Simpleness draws the design. They have a front-end developer which comes up with all the CSS and parts of the JavaScript, and then it's up to one of us to do the actual implementing into our storefront. So we have a separate Git repository for Simpleness, which we get the designs from. And after we have finished the implementation, we push them back some of the changes we did. The code merging is done manually right now, but it's an area where we're looking to improve. All of the code base that they provide is under one folder in Storefront. It's assets, images, JavaScript, CSS, and we have hooks into Ant that compile this and compress this. Right, so how we want to improve the situation is that we would like to move this folder outside the storefront and leave in the storefront just the compiled result. And that would allow us to move to a Git subtree. Currently, we have two separate repositories, one for the B2C commerce and one for their code. And we would like to use just one and then use Git downstreams and upstreams to better manage the changes in the code. Okay, Vue.js. So recently, we implemented a new Klarna checkout. It uses Vue.js. And I'm gonna tell you about what exactly and how does it work. So Vue is one of three big JavaScript frameworks for building user interfaces. next to React and Angular, which SAP took the basis of and built it Spartacus. So in comparison to other big JavaScript frameworks, Vue is allegedly, to popular opinion, simplest to pick up due to its syntax. It's the most lightweight, with the minified version coming in as just 90 kilobytes. It's fast because it uses virtual DOM, unlike jQuery. And it has the highest rating on GitHub by the star amount. So I guess nobody wants to use a dead framework, so here's a comparison of adoption. React is pretty far ahead, but this is only from the Node package manager. On GitHub, the statistics might be different. But still, 1 million and 5 million downloads, it's pretty a lot. Right, so I have prepared a demo that shows our checkout at Journey. The main thing we're proud of is that the customer can complete the whole checkout process without any page refreshes. Okay. Right, so this is the cart. User goes to the checkout. He supplies his delivery address. From that, we load dynamically delivery options for him. You can choose the option he wants. Payment is loaded. If he's a returning customer, we already know his card, and he can pay for the purchase. Yeah, of course, Johannes can pay. Yeah, so how is it glued all together? It sits on a regular JSP page. We have here some initial data initialization, and we have the mounting point for the Vue application. Vue core is included in the main app.js of the whole Journey site, and the templates called Vue files are Vue is split into templates for better code management and structuring. The templates contain, I guess, in a similar way that like the JSP templates, they have JavaScript validation built into them, and right next to the templates, you declare the validators, event handling, and other JavaScript dynamic features to help you serve the form to the user. Right, and in the end, everything Vue related, because it's essentially a script. It's compiled, minified, and added to the main project.js file. So it sits together. Right, so why would you use Vue over, for example, vanilla JavaScript or jQuery? One is that it actually has code guidelines, and because it's a framework for UI building, there's encouragement to use specific approaches, so it won't be like different projects with different JavaScript guidelines. Here it's pretty standardized. Second big advantage is that it is reactive. So what that means is if you change the data model behind, the DOM is updated automatically in the UI, which is complete contrast to the jQuery. And you don't have to worry about legacy JavaScript functions you have, because you can call them from Vue and reuse the modules you already have. And it's pretty easy to include if you have Node or just adding the library itself. Well, drawbacks might be that it might be overkill for some of the simplest forms, and that in order to use it, you need to rewrite the whole architecture, in essence, for the module you want to rebuild, because JSP is a different approach altogether. I guess some of you might think, screw it, it's easier just to use JavaScript. jQuery, right? The next, I guess, unique thing we have in Journey is that we don't use CMS Cockpit and we don't use Smart Edit, but we have WordPress for content management. And that is achieved by content proxying. All you see here is we have not gone live with the front page, but all pages in Yernia, all content is generated through WordPress. We're going live with the front page soon. So how it's done? Shortly, HTML head and body is merged from the WordPress page. It's merged with our the body is merged with our header and footer. So we have the top menu and bottom section, but the content in between is actually WordPress content. Here are some WordPress content examples. One thing I believe WordPress does better than Hybris is the whole blogging and entries, and you can manage the entries there quite better than CMS Cockpit. I'm not sure about Smart Edit. Do they have like a blog system that you can have like regular entries? Okay, so sounds interesting, but actually it has few limitations. But if, for example, you want to combine both Hybris content and WordPress content, because WordPress does not directly have any access to the Hybris database. So, for example, how do you render a product card in a WordPress-driven page? For that, we have built API that returns fully rendered product with all the calculations done. So, on top, it's WordPress. Here's the whole layout is handled by WordPress, and Hybris just supplies it with the product cards. So how does it look from the WordPress side? In essence, the front-end developers have created their similar to our CMS components for various products and like various banner layouts. I wouldn't say it's better or worse than CMS Cockpit, but it's faster than CMS Cockpit. And here, for example, in order to link to our categories and products, the most important, CMS components is the product chooser and category chooser and the brand chooser. And all of this data is supplied by Hybris to WordPress through API. Yeah, and it wouldn't be complete if we didn't have like some kind of way to navigate all this. So we also have full data replication to Hybris, where it's indexed by Solar and it's fully searchable in the global search. We have 3 different categories you can find in the global search: either product, either a WordPress article, or a store near you. Right. I guess we haven't had such advanced caching as Jans explained, but I'll explain what we have until now and what are our plans for the future, because the Black Friday is coming. Right, so we cache CMS components, web resources, and some data in the Java backend by loading cache. We have not cached all data we can, but we have concentrated on the 2 most important pages, the front page and the product page. For example, in this product card, the delivery options are cached based on the warehouse opening hours and the hour of the day. We have various different CMS cache keys, but that's nothing interesting. For example, one of the CMS components we're caching is the top menu, sorry. So the cache is rebuilt each time there are changes in the component, the category structure, or based on time-based offers like campaigns or sales. It's basically the links are either visible here or not. So since we're using Hybris caching and WordPress, we had an interesting situation just recently. We had a request from clients that they wanted to launch a campaign and to send out 200,000 SMSs with a link to Hybris page. We thought the Hybris could handle the load, and actually it did handle the load quite well, but WordPress didn't. So right now, Jānis Bogušs is working to implement EH cache or loading cache. I think he can go into more detail how it's gonna be done, but the results look quite good right now, at least. Yeah. Our future plans, as presented by Jānis Jansons, we plan to add the caching to Nginx and HA proxy for static resources until Black Friday. Okay, thanks for your time.
WordPress, they also made like the templates on the WordPress side.
Do you mean is the
So this product data which is from WordPress, which they query from the converse.
no, they can't make changes. They just have a.
This box which you need to show product data on the content pages. Like those are some kind of WordPress components, but what do they also do like a templates or?
For their reviews, all the category products from Hybris, when they not, you want to go use this, and then use this.
They just show what they want to show, and we get the data. Always.
Sometimes then you have some bugs on the website. Does your client always know which contact is synchronous or you tell who's responsible for fixing something? And I suppose WordPress is not managed by Perl.
Usually, we are the first line. So then we see what's going on and apply hotfixes we need. Jānis fixed the page in I think 1 hour or half an hour after he got the message. It was hotfixed by us. So yeah, we shared the main responsibility, I think. All right. Thanks.
2 minutes break. Jāni? Atnāk. Jā, ievelc viņu tā ekrānā. Šādā pieliek. Es nezinu, kur tev labi jāreka. Double-kliks nosaka. Es zinu.
Okay, let's continue. Yes, sure. I will talk about front-end development in Telia, what customizations we have from the standard, and a little bit something from the caching, what guys presented before, how we do the caching our way. So, my topics will be style guide. If someone doesn't know what is style guide in Telia, then I will show again. I'm always proud to show this how we work with the front end in Telia. Then I'll talk a little bit about API documentation, how we do that. Then about CMS components, what we have implemented fast way, and also OCC, how we use OCC at Telia. Kristaps will tell about that. Then a little bit about service workers and the front-end deployments, what we have in Telia. So basically, style guide. Style guide is a completely different place where you can go and see the real pages, how they look. This is the style guide. On left side, you can see all different pages what we have. These are just mocks. So basically, front-end developers, it's like we have one big team, but basically there are two, three. Now it's only one front-end developer. They do everything in style guide. So basically, they mock up CSS, HTML, and also JavaScript logic there. It can be React, it can be static HTML and CSS with a jQuery. It could be anything. Basically, it's the place where you can go, like backend developer or like business analyst, and check how it will look in the end. This is before anything happens in the Hybris development. So these pages here, we have just like a mocks for like business and for the backend developers. When these mocks are ready, then backend developers starts to work. And there comes in a little bit more about all these texts what are here, like all these texts, like our business usually requires to make them manageable. And how we do that, we have custom implementation in Hybris where they have key and value list. You can log in back office and basically add any kind of keys and values there, and it will be everything like in messages. This is how the messages looks, and the same actually style guide takes. Or, for example, these messages are not yet added from Hybris side, then in style guide designers already create these messages, and when we have like new component, new functionality, we can, like backend developer can only take these messages from the style guide and import into Hybris. So we will not have this issue what Rimi had, that they don't have a lot of text translated. Like in our case, yeah. So basically, we have already everything in place, all text and all translations we can do in advance before backend development starts doing something.
We want you to retract that statement officially.
Yes. So next subtopic. So each functionality in Telia, we have API documentation where we describe what we will request and what will pass to some external web service in this case, and what we will retrieve, like what information. We make this kind of documentation more or less for all external functionalities. So all different APIs, what we have, we try to document it. We create these kind of diagrams. And after that, the process, like before the backend development starts doing something, we have these diagrams. Then we have API description, like how exactly this API will look like. This is, I will show how this page looks. This screen. So yeah, this is the page where we, this is like analysis stage where we document how the functionality will look like, what it will be using, and like what information we will retrieve from external web service, and what information we plan to like it's the structure of the interface scheme basically, and this is information what we'll retrieve from external interface, and then information what we will pass to the front end, basically to the style guide that I showed before. So this kind of documentation we try to do for every functionality what we build with the external web services usually, and this is how we start work before the development actually starts. So this is a good way how I assume it's good for us that we try to keep everything up to date, and we can align with the front end what exactly will be passing. Yes, and basically we have a list of all kind of documentation, like for all APIs. This is done by Vladislav. He created this Confluence page. I will again show it how it looks. We have like documentation of all API calls, what front end will be using. So regarding those messages, it's internationalization. Also for that we have documentation, basically what is the endpoint, what you need to call, what is the output, what are like statuses, is there any error codes. So all that kind of information we try to document and keep in Confluence up to date. And for example, those installments, what I showed this. So first step is we create page where we assume how it will look like. And after the implementation is done, we update this page where it's like as is version, like what was deployed and what is now in the system configured and created. So this is again endpoint where it will be. Is it like after the authentication or public API call and all the structure. So the front end person who will be working with the front end can open this page and validate is correct information. Because everyone can access this, like testers.
But it's Swagger, can you have examples?
Yes. But basically, even business can open this page and search very easily in Confluence. Just so everyone can access easily this kind of information searchable in Confluence. With the Swagger, it would be a specific link. You would need to know the link where it locates. Some web service needs to host it. This is like in Confluence. Okay, this is not cloud version, but it could be cloud version. So basically, everyone can access it, and just for the availability. But Swagger, would be better for the developers, definitely. Okay, this is how we document our APIs. Yeah. But in Swagger, it's not that easy to see what you have all documented, and search is not there. If you are just searching for some string or just for some variable, it's much easier in Confluence. Yes, this is the example what I showed for the installments, how it looks like. So we have a lot of custom components in Atelier. And our business all the time wants the new components with a new look, with new functionality. And we not always do, like we don't always build real component, but we started to mock those components. So basically, this is the code what developer needs to put. Actually, not even now he doesn't need to put the code, but the end result is that form. So this form is implemented in a style guide in the front end by the front end persons. This form is built in React in the back end, but basically this form is generated by the front end. In case there's needs some design changes or some logic changes, it can be done in front end, deployed without backend change, without Hybris restarts, and actually backend developer doesn't need to do anything. So also there's a requirement to manage this form. And the management usually is from Hybris. And we have used this open source JSON editor. So basically we define schema of this specific form. And we define, and then the output is this on left side, what you can see, these kind of forms is just how you will be entered. On the right side, you see the output. The output like with the exact data. And with that exact data, some logic can be built and can be passed to some endpoint, generic third-party web service or whatever. So we have created this kind of, maybe it doesn't look that good, but this is back office. And in back office, there's like this predefined schema. Basically, it will tell, okay, these are string input fields, but it can be also okay, here's also select boxes. Is it visual? But as I showed here, it can be also like color, checking the color, select box, or multiple choices selector. It can be like multiple kind of forms. And we don't need to do any backend development for that. We just need the schema. It's also JSON format. We can create, using this schema, we are just creating new React component. We define the schema, we put it there, and then how it looks for the management, for the managers who open back office. And if they need to add new form or change the text of the form, they can go just here, open it, add it, and we don't need to do any backend development. And this is like really fast for different kind of forms. What our business wants. This is how we implemented it. This is just example of one another JSON form. Yeah, but with Firebase forms, you need to do backend development. Yeah, you need to have a developer who will do that, and yeah. So basically, here it's configurable, easy, and you can create defined schemas for any kind of forms. And front-end developers are not any more restricted to backend developers. They don't need any more backend developers. So these kind of forms, this is also one example. This is like real page, how it looks. There's like 3 components. Okay, you don't see the third one, but basically 2 components. One is banner component, and the second one is custom React form component. And this is how it looks in CMS Cockpit. So basically, you have banner component, and this dynamic form component in CMS Cockpit looks like that. And then previous slide I showed the management of this form looks like that in a back office. It's long story. We have like pull requests for 1 year, I think, or something like that. There's no budget for that, but we have budget for these kind of activities. No, what is that? Steps? No, it's your turn. Next one. Christmas will show a little bit from his side. Next, forward or mouse.
So works. Yeah. Okay, ready. So doesn't work. Okay.
No. Yeah.
So OCC in Telia, we had like one use case where we had requirements. You can read them here. Basically, it was that we needed to create few CMS pages, which needed to consist of manageable components, and they should be manageable in CMS Cockpit by CMS managers. On these pages, we needed possibility to add any already existing components that we have. And then we had like business requirements that on this page at the top and bottom we needed possibility to add components that are showed when the page is loaded, and in the middle we needed to show some tariff component and also some other components which were like depending on the selected data in this tariff component. Also, this tariff component data was not like filled from some fields, attributes, but it was like dynamic data coming from facades. And it was different depending in which segment customer was in or which country was selected. And also, I don't know if it was like a requirement or what, but it should be rendered by React. So what we did, first thing what I want to say, we have like a few, maybe 10 React components, and so that all React JavaScript is not loaded for every page, we use CMS before view handler, I think, and it like goes through the components, and then if this kind of component is, if some kind of component, in this case tariff country selector component is in the CMS page, then this JavaScript is added. Next, so there was basically management requirements were like quite strict how it needed to work, and they wanted to easily manage all this in CMS Cockpit, and there was some structure that I will show later, but basically we created the VM, we created few layouts, impexes for CMS templates and pages, and then so how React knows that React needs to do something in this middle component. Our idea was that in the template we render page slots, and we did changes to CMS component tag. We extended it and added new parameter, show slot UID, which later was used by React. And when the page is loaded, then basically you can see that there is this marked with red, the content slot UID, and this attribute data dynamic slot. So React knows that all divs which are with this attribute needs to make requests for these slots. Okay, yeah, what I said. So we use OCC, with which you can get for page you can get slots. For slots you can get components, also all kind of other data you can get in this extension. So we created telecommerce web services, and yeah, then the React makes the request passing the slot UID, and also we had requirement to pass country code parameter, because the idea was that depending what country is selected, there was CMS restriction made for country codes and regions. So this we needed that requesting this request backend returns only components in this slot that like are valid for this country. So yeah, and the bottom it's a response. What you can see, the first thing is that it returns component list in the sequence in which they are added in CMS Cockpit. One thing is type. So frontend basically knowing the type knows how to render this component in frontend. It's same idea that we have in Hybris, that we have for component we have controller and GSP page, yes, and then in this GSP page this component is rendered. So by knowing the type, for example, CMS paragraph component or FAQ contextual component, React basically knows how to render data, how to render this component with data returned. And as this tariff component is not with static data, but how to say dynamic, we added extra field endpoint, which is URL, which frontend again requests and gets response for this component. So, yep, and then using this resource, React gets two things. Sorry, yeah. first is the component itself again, and then all the data that is in component. In our case, it was tariff structure. Yeah, why we needed, so this is how this page looks in CMS cockpit. Number one is footer and header. So these components that are added there are loaded when the page is opened. And in second content slot is this dynamic content slot. So yeah, we had like a requirement that there was landline and mobile tariffs. So one side is for one kind of tariffs and another is for other kind of tariffs. So in each side there is this tariff component on the top, which contains this endpoint, but endpoint that frontend is requesting, and then all other components are any component that we have created in Hybris for now, and by adding these country restrictions, what I mentioned, they are or are not returned to the front end. Yeah, and this is how the page looks. So again, with number one, these are like the components that you get on page load, and in the block with number two, this is dynamically returned from the endpoint URL. Maybe it will be easier if I will show it. Can I move these options?
Yeah.
Okay. So how this works? So when the page is opened, okay. So when the page is opened, the first page is loaded, and there's the country selector. Yep. What? Cool. Yep. So these are the standard components that are added on each tariff page, but which are not depending on anything. I mean, not on the selected country. And then when customers select some country, there are made. So React makes requests for the slot. In response, it gets all the components that are in this slot. In this case, it's a tariff component, and at the bottom there is FAQ component. So this FAQ component is rendered already from this response. Actually not, but yeah. There's actually additional requests made also for this, but it's not related to OCC. And then, as you can see, for this, there is additional endpoint, and then React calls this endpoint and gets all the data for this component. In this case, we had 2 slots defined, because for each slot there was additional requirements, and as you can see, each slot is rendered a little bit different. There's only 1 column for the data, there are 2. So they're like different components which are at the backend are calling different facade methods. So yeah, that's it. Questions?
No.
I'm continuing.
Is it possible to manage it somehow from this or backend? Components, how do you
have some specific CMS content that just calculate this calculate? Yes. It's calculate, it's had a footer and then they have a template, it had a footer, and then there are in this template okay, right. So there are four, in this case there are four slots. The first two are for components that are logged on page load, and actually, like with number 2, there are 2 slots. Each slot has like different components, and each of these different components has different endpoints when front end calls. And we could add more these, like we could add more slots in the template with this attribute dynamic content slot. And then in this slot again add some component for which we fill this extra URL that frontend can call and get some data. So it's like idea is that for every component you can add some additional endpoint that frontend can call and get some additional data. That endpoint is used on Hybris and Hybris in order to respond. Yes. These endpoints, of course, are like directed to the core.
Some are custom, some are on OCC. But this is like one way of work how basically Spartacus will work with CMS living on the Hybris, which is just our additional customization and trying to try this way of implementing some custom components. I'm not sure if like they will do it again the same way. Most probably we'll just made custom API endpoint without using OCC. But we had just such complicated management requirements from the CMS cockpit, so we tried the standard approach using OCC. Okay, I will continue with 2 more topics. One is Workbox, basically service workers. Who knows how service workers works? Okay, so basically you have application browser, you open the page and the browser checks is there a service worker on this page. There's no service worker, it continues the request to the server, basically backend. In case you have service worker, it retrieves information from the cache which is stored locally in a browser. This is in the details explaining how service workers work. Basically, your device makes first request and checks if there's like service worker active. If no, then it goes and fetch from the network any type of information. It could be AJAX request, it could be image, basically all requests what your browser does to the domain, to the website, it works this way. Also, the browser checks is there like service worker, also it makes the request is there like service worker registered. And then you need, if like in browser there's code in JavaScript, and it just tries to check, okay, this browser supports service worker, then I can install and activate the service workers. And basically then the browser knows, okay, on this website there's installed service worker, then all my logic will be retrieved using service worker. So all requests after the service worker is installed in the browser, it happens in backend in JavaScript. It happens with this kind of code example. So basically when the browser opens the page, okay, checks I need to install, it installs the service worker, then all logic goes through the service worker. And in service worker, in a JavaScript, you can define anything, how the network requests are done. It can cache locally in a browser, cache image, it can cache AJAX request. Basically what Jānis presented, that information can be cached in a browser in a service worker. But it will be for one client, but for upcoming requests, then it could use the service worker, not the server. So basically, browser installs the service worker, and it can store it in local caches. In browser, there are multiple caches. One is like IndexedDB and then Cache API, and basically then it stores the cache and retrieves information from cache. Different browsers has different limitations, but more or less it's stable and can be used. So this is how Service Worker looks in Atelier. There's like a JavaScript file. It's called from some init script on a page load. For example, it can be in-page JavaScript that will just say, okay, Service Worker locates here, the logic for the Service Worker. And this is a workbox. Workbox basically is a set of libraries provided by Google, and it's really easy to configure what kind of resources will be cached and how. And for example, here you can see exact like what information we're caching. So we're caching images, we're caching font files, and also we can cache the text HTML requests and all that kind of information. And then also we can define how long this is cache stored and how exactly it will be cached. So with Workbox, it's like easy tool to set up the Service Worker magic, how it works. You just edit this file, configure what you want, and then everything else will be done by this library with the browser interactions and supporting multiple browsers. So basically you can cache images, requests and anything, and define even if you are like offline, you can use information from the cache. So if your train, your network connection is bad, you can put the order locally in your browser in your phone. So this approach will be also used in Spartacus. It's still not there, but it will be. Some limitation, yeah. About static JavaScript files, yes. About medias, yes. There's this context from the Hybris, like if you upload different image. But for the like static JavaScript files, I will show a little bit later how we handle that. But if it's completely static resource, then no, then there's no specific like cache defined. But I will just show, and maybe it will answer how it works. It can be cached, and I can define how long it will be.
It's only time limitation, or there's some other mechanism?
Time. But I will get back to that point. It's okay. Some limitations. Basically, in Chrome and different browsers, there are different limitations. So basically, in Explorer, there's some limitation. In Safari, it's a little bit like biggest limitation. This basically smallest size you can store in Safari. It's like in mobile browser on your phone. But in Chrome and Firefox, technically, it's unlimited. You can store a lot. Basically, how big is your hard disk? Yeah.
Single site or for all of the service workers together?
All. Here is support, where the service workers are supported in which browsers. Basically, all normal browsers nowadays support service workers. So, yes?
There's a way to block them. I noticed there's a lot of them.
You just send requests that you want a fresh version. You can always like make disable cache in your browser, and then it should ignore actually the service worker. But you can see that in network. And yes, how basically it looks for the end client, for the developer. All these requests, like all requests, are from the service worker, except the first one when it's like homepage, and then we have some kind of OCC kind of component which with Ajax calls additional call, and so that one information we don't store in service worker, but it could be stored. So all these kind of resources are stored in a service worker locally in your browser. Yanis? Sorry. My next subtopic about front-end caches, maybe it a little bit I will answer you. So basically, service worker caches all JavaScript files, and if we change some logic in JavaScript, then we need up-to-date version. And so basically, these are our JavaScript logic files, and it has some like version from Hybris, what kind of version it is. And all this information are retrieved from the cache, basically service worker. And in case we want to update this one, then we have built-in process. It's same in Aquas in dev in production system, how front-end changes can be deployed fast to the client and cache will be invalidated. So basically, it's a Jenkins job which takes front-end, compiles everything, and this compiled version commits to the Hybris. This is how the commit looks in Bitbucket. Basically, you see that this file is changed, and basically it's already concatenated changes from the front end. And so all additional front end changes are committed directly committed to our branch what we have on that server. So on that server, we just need then pull the code. Okay, we have up-to-date file in the system, but still in the browser it's like version 1. And then we need to update this version. For that, we have another Jenkins job that actually pulls the code and updates the version, what I showed in network request. So basically, this is our implementation, how we update the version. It's in Jenkins just a call to our server, some hack endpoint, basically update config. What it does, it just puts some new date or some new value on the value in the properties file in Hybris. And in the end, then all these versions are updated using like from the administration panel. You can also like invalidate manually it or call this Jenkins job, and it will invalidate and make different values for this new files. And basically then in the end, I have changed the version using Jenkins job, and you see that all these files are again requested from the network endpoint backend basically. Did it answer your questions? Partly, yeah.
Banner one day.
So for banners we have component. This banners we don't cache. We have like old banners and restrictions. But the images have normal image cache. If you want different banner, you just need go to the CMS cockpit, upload new banner, and it will invalidate standard Hybris caching, what we have for CMS components, and it also have new context for the media, and that image will be retrieved again. So we don't have anything fancy on the backend side. We still have all CMS components, standard ones, and all that invalidation works as it works from the CMS cockpit and you update content. But we have like all default CMS component caches.
In case of Perlcache, it was, I would say Perlcache was, well, it was standard, but it was like a specific scenario. We used it because we couldn't really utilize the engine caching, because we also had to tag these first-line recommendations. But if you can cache a resource using, let's say, Nginx, you can define it with different paths or scenarios, how you would separate for how long it would cache. Like a separate zone, separate time period. Yeah, no, it wasn't.
No more questions? Great. Then where's our favorite part of this presentations? It's Kahoot. Please take your phones and open kahoot.it. Let's wait 20 players and we'll start. I don't know. 279366. Doesn't work? Okay, then no Kahoot. Unlimited version.
Log out, log in. It's broken.
Okay, no Kahoot this time.
Oh my god!
Sorry. They will come offline Kahoot later. Your preference? Yeah, but we can still go to do the quiz. Let's then just get answers to these questions. Okay. Choose one of the expensive ones. I think we can end. Next time, yes, too. Jans, you will end?
Thank you.